In this video, we will continue with the same 2D platformer example that we have been developing in different game engines. We will be adding some effects to improve the game visuals. First by adding some sound effects and some music score. Then, we will be adding damage and death effects based on particle systems, which should teach us how to use them in games. We have a lot of ground to cover. So let's dive into Godot. If we want sounds and music in our game, we will have first to import them into the game file system. We have already downloaded some files with examples of sounds and music that we will be putting in the description. Let's go to the folder where the files were downloaded and copy them to a new folder that we have created named SFX. Once the files are copied, let's check in their properties to see if they have or not the loop attribute activated, and deactivate it in case it is not needed. Don't forget to click the re-import button to apply the change. Let's add now the possibility for the player to play some sounds. For this, let's add a new node to the player node by clicking on the add sign on the project hierarchy. In the search box type audio, and from the list select the audio stream player 2D. Right-click on the node, and select the option rename. We will be using this one for the sound effect with the sword, so we can rename it to Sword Swoosh. Select from the Project Files pane the sound effect file associated with the sword FX and drag it to the right pane where you will be able to find a slot named Stream. Let's now add the code that will play the sound. But first, let's fix a typo in the name of the node as we have forgotten to add a W. Open the player script. At the beginning of the script, where we have been adding the variables to be initialized on the ready function, let's add a new variable sword attack that will get the reference to the audio steam object just created. Now, let's go to the attack function and let's play the sound effect associated with the sword when the player is attacking. By calling the node method play, this will have the sound file that we have associated earlier on to be played. Let's run the game and see, or better said, if we hear the sound effect being played. And we listen correctly to the sound effect being played by Godot. Let's go back to the game view and let's repeat the process for the jump sound effect. Let's take the chance to change the name of the audio objects, and add SFX appended at the front to make it more clearly associated with sound effects. In the state associated with the jump, add the play instruction. Run the game to check if the sound is playing correctly. Now, let's go back to the game view. And let's open up the enemy skeleton node. And let's add also some sound effects to it. Add a new node audio stream player. And let's rename it to SFX enemy hit, which as its name indicates will be played when the enemy is hit. From the project files, drag into the stream field the sound file for the hit effect. Let's edit the enemy script now, and let's add at the top. Let's get the reference to the enemy hit node into a new variable SFX enemy hit. Then, in the take damage function, let's play the sound effect by invoking the SFX enemy hit play method. Let's run the game to check the result. And, as expected, the enemy is reproducing the hit effect correctly. We may have to adjust later on the different volumes associated with each of the sound effects. Let's go back to the game view to add the music to the game. For this, let's add a script to the top node named Game in the Scene. We will be naming it as Main Game. Then, add to the game node a new audio stream player object and rename it to Music Game. Drag the music file into the stream field. Let's copy from the enemy script the initialization of the node instructions. And let's paste it into the main game script. Let's call the object Music Game, and let's load the Music Game reference in the get node. Now, in the ready function, let's play the music. Let's run the game. And we have music, again maybe too loud. So we have some adjustments of the overall volumes to be done. So, let's make the changes now. By adjusting in the different audio stream nodes the volume dB field from the inspector. We will do it in front of the camera just for the music, but you will have to do it for all sound objects. Let's run the game. And, it seems better. When you think about Game Mojo, apart from sound effects and music, we usually refer to the feedback that the game gives to the player for each of its actions. So, for example, if the player is hitting an object, that object should show that it is receiving the impact. Currently, our enemy plays a hit animation and is slightly knocked backward. How can we improve the effect even more? Well, by adding particles effects on each impact. We will put in the description of the video the reference to 2 very interesting talks about Game Mojo that will help you understand it. Let's create our hit particles. For this, let's create a new empty 2D scene. Add a new node by right-clicking on the project hierarchy or by clicking on the add sign. In the search box type particle. And from the list select the Particles 2D option. Right-click on the node, and from the menu choose the option Make Scene Root, to make it the root of the scene. We can see that there is a yellow warning sign next to the name of the Particles node. This is to tell us that the configuration is incorrect, and we have not yet created the process material associated with it and that is causing the particles not to be rendered. Let's create on the empty slot. And it will open a new menu, where we will be choosing the option New Particles Material. Click again in the slot, which is now referring to a specific particles material. And you can see that a new group of options shows up in the inspector with all the particles configuration parameters. We should also already be able to see the particles being generated, but the camera is not pointed at the right place in the scene. So zoom out and drag the camera until we have the particles in the center of our window. We should see a series of particles being sent downwards pulled by gravity. So, let's start by reducing the gravity to a lower value. In our case we will be setting it to 1, but you can play with your values to achieve the results that you want for your effect. Now, let's change the emission shape from a point to a sphere. We start to see the particles appearing in a circular shape around the origin. Let's now adjust the direction. By default, particles in Godot engine are initialized pointing to the right. We see them falling because the gravity is very high and annuls the movement to the right. We can see this in the vector direction. There is a 1 in the x field, indicating that the particles are being sent to the right. Let's adjust first the spread from 45 degrees to 180, which should make the particles be instanced more regularly around the origin. And then, let's set the x direction to 0, and set the y to -1 to have the particles slightly going up before being pulled down. Since the particles are not going very far, let's adjust the initial speed to a value to allow them to have some movement. After trying several values, let's leave it between 6 to 7. Let's increase slightly the gravity as to have the particles going down after the initial up impulse. Let's go up to the emission parameters, increase the explosiveness to 1. And let's increase the number of particles to 16. We would like for the particles to become smaller throughout their lifespan, so scroll down to the scale field. And from the scale curve chooses the option of a new curve texture. It will open a new set of parameters, and from in the curve editor, drag the second point down to make the size of the texture to be reduced over time. In the scene view, we should see the particles going smaller and then disappearing. For this effect, since our enemy skeleton is mostly white, we will not touch the color options of the particles system. Before continuing, let's save the scene with the name hit particles, as we will need it later. To finish setting it up, and since we don't want our hit effect to be continuously being played, let's set the option one shot to be checked. This will cause the particle effects to be generated only one time, and then to be disabled. This will also cause us to have to start the emission of the particles system in the code. In the video games, we have always to think about memory management. So that means that if we are generating one emission of particles, once it has been done, we should delete it from the memory to clear the memory from other objects not used anymore. We can do this very easily. From the particles themselves, let's add a script to the particles node, by right-clicking on the node or by clicking on the add sign, and then choosing the option add script. Let's name it hit particles. Delete all the code and leave only the first line that extends the particles 2D. Let's go back to the hit particles scene view and let's add a new node to the scene. In the search box type timer, and select the timer object from the list. In the inspector, let's set the one shot and the auto start parameters to true or checked, and let's reduce the wait time field to 0.05. Then, click on the Node tab from the inspector top bar. And from the list of signals, let's choose the timeout one. Click on the button Connect in each for the dialog boxes to continue. In the hit particles, the system has created the function associated with the signal timeout, and there we can add the queue free method to clear the node. Save all, and let's go to the game view. Let's start to code the functions that will generate the particles when the characters are suffering damage. Open up to the enemy skeleton script, and at the top of the file, let's preload the hit effect scene. For this, let's define a variable prefab hit that will receive the result of preloading the hit effect scene. The preload function receives as a parameter the entire path to the file holding the scene. Now, in the take damage function, we will need to instantiate the effect at the position of the enemy each time it will receive an impact. Since the enemy will be moving under the knockback, we will also need to have the effect to be added to the enemy hierarchy as a child. So, let's start by instantiating the effect by calling the instantiate method from the prefab hit variable that we declared earlier. We will be saving it under the variable hit effect. Then, let's set the position of the effect just created to the position of the enemy by setting the position propriety of the hit effect variable to the position of the enemy. Let's set the particles to be emitting. And then let's make it a child of enemy skeleton by invoking the addChild method. This will make the particles follow all the changes applied to the enemy skeleton, like movement, rotation, or deletion. Let's run the game, and let's try to perform some damage on the enemy to check if the hit effect is shown. Nope, it is not shown. It may be instantiated behind the enemy. Let's go to the hit particles scene view, and in the inspector, scroll down to the Z index section. Set the index to 10. This will make sure that the particles will be rendered on top of everything. Let's run again the game. End. Yes, we can see the particles. Now let's replicate the same process for the player. Open up the player script, and at the beginning of the script, let's preload the hit particles into a variable prefab hit. Let's go to the take damage function of the player, and let's add the code that will instantiate the hit particles effects, but with some slight changes to show another way to do it. Let's instantiate into a new variable hit effect the hit particles. Now, before setting the position, let's make the effect a child of the player, and by using the method getParent, which will return that parent of the current object where the script is being played. Then, now that the hit effect is a child of the player, if we want to set its position in the scene, we need to use the global position variable and set it to the position of the player. This is because, until now, the hit effect is a child of the player, so it would be using local coordinates referred to the player. Let's set the emitting to true as to emit the particles. Run the game to check if the particles are instantiated. Now, let's add the death animation to the enemy. We have already created it when creating the enemy, and we can quickly check in the animated sprite that the sprites are correctly set up and that the animation is working. We forgot to uncheck the loop when we created it. Let's uncheck it, and it should be ready to be called from the enemy script. Let's go to the enemy skeleton script. Let's got the execute state function. And under the state dead, let's run the death animation. First, check if the animation death is not already being played. And then, if not, let's play it. Let's delete the queue free as we don't want to delete the character yet. Let's run the game. We can't. There is an error with the code that we have just added. Oh, we have put a comma instead of a dot. Let's fix it. Let's run the game again and try to kill the enemy. Nope. The enemy disappears immediately and doesn't play the full animation. Let's double check the code. Okay. In the take damage, we still had the code to check if the life was below 0, and to delete the character. Let's remove it. Let's run the game again. End. The death animation is being played correctly. We cannot do the same for the player, because the sprite that we have been using doesn't have a death animation, so what we will do is make it disappear in an explosion of particles. But, since it would be a complementary effect on the enemy, we will build the effect on the enemy skeleton and then apply it to the player. So, let's create a new scene, and in it, let's create a new particle 2D, as we have done earlier on in the video. Let's create the particle material and then let's configure the system to look similar to an explosion. First, let's go to the direction and set the X to 0. Increase the spread up to 180 degrees. Then, set gravity to 0. Increase the initial speed to 32. And then, under time, set explosiveness to 1. Increase the number of particles to 32 or higher. We can see that the particles are expanding in a circular shape. Let's increase the number of particles to 100, and let's reduce the lifetime to 0.5. Let's go back to the initial speed section. And let's increase the velocity random to 1. And now we should see the particles appear in a more random order in the game view. Let's change the lifetime to 0.8 or 0.9. Let's go down to the scale section and create a new curve texture. Click on it to edit it. And place the second point on the line to be near 0. Too fast. Let's reduce the initial speed to 16. Looks better. Add a script to the particles that will be used for the timeout function and name it Death Particles Effect. Delete all the code and keep only the extends instruction. Save the scene as Death Particles Effect. Add the timer node to the particles. And set the one-shot and auto start to true or checked. Let's reduce the time to 0.5. And then, let's click on the Node tab on the inspector header. Select the timeout signal and click twice on the Connect button to create the timeout function in the script we created earlier on. Let's add the queue-free method to delete the particles node once the timeout is reached. Let's go now to the enemy skeleton script. At the top, let's preload the Death Particles Effect scene. Let's go to the take damage function and copy the hit particles code. And then in the execute state, under the dead state, paste it. Adjust the code to reflect the new variables that we have defined for the death effect. Let's delete the hit effect sound playing. It seems that we have a typo with the death effects emitting line of code. We have missed an E. Let's quickly fix it. Let's run the game and kill the enemy. Okay. We can see that the particles are always there, but we have set it up to be one shot, so we have a new bug. Let's check the code. Okay. The problem is related to the place where we have put the code for the particles. Once the enemy is dead, the dead state will constantly be executed until the enemy will have been deleted, which means that we are constantly creating particles. Let's move the code from the dead state to the hurt state, where we are testing if life is below 0 and set the dead trigger to true. Let's run the game. And now we can see that the death particles are showing up, but the enemy when dead is still moving under the knockback. Let's fix it by setting the movement to be 0 when the enemy is dead. Let's run again the game. And now the enemy dies in the current place. Let's copy all the code from the enemy into the player. Okay, done. But we will be having a slight issue, as we have seen that the player knockback was not yet adjusted to the direction of the movement. We will fix it after checking if the particles are appearing. Let's try it. Okay. Apart that, with the wrong knockback and the damages done to the player is too small, we can see that we have the same problem that we had previously with the enemy. As soon the player is dead, we are deleting it, which automatically resets the camera. So, let's delete the cue free method. And then, let's add the code to take into account when doing the knockback the direction of the player. So, at the top of the player script, let's create a new variable moving right and set it to true. Then, in the handle input, let's set it to true when moving to the right, and false when moving to the left. Let's check the game. The knockback is still somewhat failing, and the damage is still too small to quickly check the death effect and when the player is dead. So, let's change it. The first thing is to increase the damage to the player. Let's temporarily multiply the damage received by 10. Then, in the death, Let's disable the main physics process by invoking set physics process to false. And let's stop rendering the node by setting the visible propriety to false. In the next episodes, we will deal with respawning the player and checkpoints. Let's try it. And everything seems to be running as intended. In the next episode, we deal with respawns and checkpoints and add different screens to the game to deal with the game flow. Like this video. If it has been the case, consider subscribing, giving a like, and clicking on the notification button. If you have any questions, problems, or comments, don't hesitate in putting a comment and we will answer as fast as we could. See you in the next video, game developers.